Question 3. We've got cyclohexene can be prepared by the dehydration of cyclohexanol using concentrated phosphoric acid. You usually use concentrated sulfuric acid, but in this case they've used concentrated phosphoric acid. It'll do the same thing. Prepared cyclohexene by placing 10 cm cubed of cyclohexanol density 0.96 into a round bottom flask. So we could use density equals mass over volume. Here we've got the density, we've got the volume. We could work out therefore the mass of cyclohexene that we've got. Phosphoric acid added to the flask. Student added anti-bumping granules before heating to prevent large bubbles forming. Student heated the mixture, distilled off the cyclohexene. The distillate was poured into a separating funnel and washed by shaking with sodium carbonate. Presumably that's to remove any of the phosphoric acid that's remaining. Sodium carbonate reacts with acids. Periodically the separating funnel was inverted and the tap opened, presumably because we're getting sodium carbonate makes bubbles of carbon dioxide with an acid. So sodium carbonate can be used to test for acids, but it makes carbon dioxide. So separating funnel was inverted and tap open, presumably to release the pressure. The aqueous layer was discarded and the final organic product was dried using anhydrous calcium chloride. That's a solid that doesn't dissolve. It's an insoluble solid and it'll absorb water, so it remains as lumps basically in there, and it will absorb any water. After the product was dried, the drying reagent was removed using filtration, so you can remove it because it doesn't dissolve under reduced pressure. So you use a Buchner funnel and a side arm connected to the tap, so reduced pressure or vacuum filtration. Calculate the percentage yield of cyclohexene. So we've got the amount of cyclohexene that we've made. Originally we've got density equals mass over volume for the cyclohexanol. So we know 10 centimeter cubed, density 0.96. So we've got cyclohexanol, density is mass over volume. We've been given the density, we've been given the volume. Density is in grams per centimetre cubed, so we leave the volume in centimetre cubed when we do density as mass over volume. Mass is 0.96 times 10, 9.6 grams of cyclohexanol. We can work out the MR of cyclohexanol, and we can work out the number of moles of cyclohexanol, because moles is mass divided by MR, 9.6 divided by 100. I've got 0.096 moles of cyclohexanol. Now, 1 mole of cyclohexanol makes 1 mole of cyclohexene, so 0.96 moles of cyclohexanol should make 0.96 moles of cyclohexene if I get 100% yield. So I've got 0.096 moles of cyclohexene. The MR of cyclohexene I can work out as 82, so the moles of cyclohexene, moles is mass divided by MR, so 0.096 moles equals mass divided by 82. 82 multiplied by 0.96 tells me that I should make 7.87 grams of cyclohexene. I make 5.97 moles of cyclohexene, so I divide 5.97 by 7.87 and it'll give me 76%. They're allowing somewhere between 75.8 and 76%. Describe textured reaction on the product to show that cyclohexanol had been dehydrated. Well, it's making cyclohexene, so the test for a double bond is bromine water. Would go from orange to colourless. Suggest why sodium carbonate was used to wash the distillate. That's to remove any acid left in the flask, so we're using phosphoric acid, so it'll remove any acid. Explain why it's important to open the tap of the separating funnel. So the sodium carbonate and the acid are going to make bubbles of carbon dioxide. You need to release that. Give a property of anhydrous calcium chloride other than its ability to absorb water that makes it suitable as a drying reagent. It remains as a solid, it doesn't dissolve, so it remains as a solid, so once it's absorbed any water in the mixture it can be filtered off. Describe the apparatus used to remove this drying agent. Well, you use a special funnel called a Buchner funnel, and you use a side arm flask or a Buchner flask connected to the tap for vacuum filtration or reduced pressure filtration. So a Buchner funnel, you can actually call it a flat bottom funnel as well, but its real name is a Buchner funnel. It contains some filter paper, of course. and the Buckner flask underneath, or a sidearm flask, is connected to the tap to a vacuum pump. A sample of cyclohexene had been contaminated with cyclohexanol. The cyclohexene can be separated from cyclohexanol by column chromatography. Silica gel is used as the stationary phase, and hexane as the mobile phase. So silica gel will stay in place, and any polar molecules will adhere to that, will be retained by that and stick to it essentially. Any non-polar molecules will move more quickly past the stationary phase, and hexane is the mobile phase that will be used to rise up the column, or run down the column rather. Column chromatography runs from top down to bottom, unlike paper chromatography that runs from bottom to top, and that will pull the cyclohexene through the column. Explain why cyclohexene has a shorter retention time. A shorter retention time means it's going to run through the column more quickly than cyclohexanol. It's because cyclohexanol has got an oxygen to hydrogen, a very, very polar bond. So the polar bond is going to adhere or be retained on the silica gel. So cyclohexene is non-polar, cyclohexanol is polar. It's going to have hydrogen bonds. So the cyclohexanol has, you could say, greater affinity, attraction, retention to the stationary phase. It's basically going to stick to the stationary phase and not move as far or as quickly as the cyclohexene, which is non-polar. Explain how an infrared spectrum would confirm that cyclohexene obtained from the chromatography column did not contain any cyclohexanol. Then you've got to look in your data book and you'll find there's no peak at 3,230 to 3,550, which would indicate the presence of an OH bond or an alkyl, an ol.